All right, back at it here, 9-3. Trying to get through this. If you have not done the Check Your Understanding on page 574, please pause the video and do so now. Please. Okay, I can't impress upon you. If you are really in this to do well, you've got to do the things that I ask you to in the videos. I don't see you enough. I see you one day a week. Okay? Through the computer, I don't know what's happening in your house. What if you're playing Rocket League or whatever that stuff is, man? I don't know. So I need you guys to be with me if you want to be successful on this test. Okay? That's the whole point of this, right? Two things. Learning what it takes to do the work in a college level class, which no doubt you're getting that. Okay? And the other thing is giving you a chance to pass that test. So that's what we're trying to do. Okay? So if you don't listen to me and you're at home and you're just copying down what I do, that's fine. You're not learning it. You're just copying it down. You say, well, I'll look it up. Not learning it. Says a college professor suspects that students at his school are getting less than 8 hours of sleep a night on average. To test his belief, the professor asked a random sample of 28 students. Of course, they couldn't just give us 30 students. 28 students. How much sleep did you get last night? Here are the data. Okay, and then they go through it all. Do these data, I never like data as a word, because I never know how to say it. Does this data, I would say, but this says do these data, because they're talking plural. Do these data provide convincing evidence in support of the professor's suspicion? Carry out a significance test at the 0.05 level to help answer this question. Let's do it. Let's do it. State. Let's state what we want to do. We want to perform a significance test. We want to perform a significance test to see what? What are we trying to learn? To see if students at a school are getting less than 8 hours of sleep. We want to perform a significance test to see if students at this school are getting less than 8 hours of sleep. I know I am, I'll tell you that. Okay, so let's do our hypothesis. The hypothesis, what are we talking about? Are we talking proportions or are we talking means? If we're talking proportions, we use P. If we're talking means, we use mu. We're talking mu. Okay? Mu equals 8, where mu equals the number of hours of sleep, or the average number, I guess I should say, right? The average number of hours of sleep. Okay, so we're talking about I could say the average numbers of sleep at this professor's school, but I think that's going to be good enough. So now the alternate is what he's thinking. He's thinking it's less than that. Okay, so he's thinking it's less than 8. That's a really good state. That's a really good start to this problem. Okay, so now we're going to start our plan step. Okay, we're going to do the plan step. And so for the plan step, okay, the first thing I want to do is I want to name my test. Okay, so it is a 1 sample t-test for means. 1 sample t-test for means. Okay, so let's do it. We've got our random, we've got our normal, we've got our independent. It states it was a random sample. It states it was a random sample. Normal. Well, n is 28. If n was 30, it would be good. N's not 30, okay? So we've got to go to our calculator and type all this stuff in. So I go to my stat and I go to my edit, stat edit, and I type all that stuff in, okay? So since I'm going to show you the graph right there, okay? Roughly symmetric, no outliers or skewed. Okay, I'm just going to put that here, okay? Save us a little time. If you need help doing that part, you tell me and I'll tell you how to do it, okay? But we are going to say the graph shows no severe skew or outliers, okay? Now you have to show your graph. You have to draw a picture, okay? I showed you the picture. I'm not going to go through and draw it. But you're going to have to if you want credit. Independent. What do we have, 28? 28 is less than or equal to 10% of students at the professor's school. All right? That's a really good job right there. That's a 2 right there. You do that part right there, you get a 2 with this, on this question. Okay? The best you can get is a 4. You go through and you're getting 2s on your free response questions. Guess what? You're going to pass the test. You are going to pass the test. Okay? So if you're missing this, you can rewind the video, copy it. Let me make sure I'm taping. Can't have another one of those disasters. I'm going to throw a party for myself when my last video is done, I can tell you that. All right, so now we got to do our do step. We're going to do our do step. So we have to find a t-score, okay? And so the t-score is the x-bar, which is your mean, sample mean, minus the mean of the population divided by the sample standard deviation divided by the square root of n. Now, I didn't type this into the calculator. I'm hoping that you did. You'll agree with the stuff that they have in the book. 6.643 for a mean. 6.643 minus the 8 that the professor's using as part of his hypothesis. Okay, and then the sample standard deviation is 1.981. So 1.981 divided by the square root of 28. What happens as this number goes up, your variability goes down, correct? So we're going to get a sample t-value, a t-statistic of negative 3.625. So right away, when you get that, there should be something going off. You're saying, wait a minute, we've got something here, right? So we're going to do t-CDF, okay? Negative 999 to negative 3.625. We want to know in our null hypothesis if it's less than that, not null, excuse me, alternate hypothesis if it's less than that. So we know what this is going to be, right? We know this is going to be, very close to 0. P-value looks like it's got four zeros or 3 zeros, 1, 2, 3, 6. Okay, so 0.06%. So let's conclude. With a p-value this low, we reject the null hypothesis. There is sufficient evidence to say that students at the school are getting less than 8 hours of sleep. Okay? So there's your check your understanding. Really good job at that. Okay? Pretty easy problem if you want my honest opinion. Okay, you need to know how to do that. Okay, you need to know how to do that. I'm not going to sugarcoat anything. You need to know how to do that. And if you don't, see me. We'll work it out. Okay, that wasn't a hard problem. There was nothing about that. That was as straightforward as it gets. Okay. So, what type of an error could we have made? What type of an error could we have made? Well, what did we do? We rejected the null. So if we rejected the null, that means that we made a type 1 error. Okay, we rejected the null, but we made a mistake. Okay, we said that it was less than 8 hours when really they are getting 8 hours of sleep. Okay, so you want to always be thinking about those errors. Okay, because I'm telling you, you're going to see that. You're going to see it. All right. So let's keep moving. Let's keep on moving. Keep the train going. Choo choo. All right, here we go. So it says, don't break the ice. In the children's game, Don't Break the Ice, small plastic ice cubes are squeezed into a square frame. Each child takes turns tapping out a cube of ice with a plastic hammer, hoping that the remaining cubes don't collapse. For the game to work correctly, the cubes must be big enough so they hold each other in place. But not so big they're too difficult to tap out. The machine that produces the plastic ice cubes is designed to make cubes that are 29.5 millimeters wide, but the actual width varies a little. To make sure the machine is working well, a supervisor inspects a random sample of 50 cubes each hour and measures their width. The fathom output below summarizes the data from a sample taken during 1 hour. So we like this, okay, we like this. So the first one is the mean, okay, the mean, and this is the sample mean. The count, there were 50 of them. The standard deviation is 0.0934676. The standard error is next. The min, the quartile, the median, the third quartile, the max. They've got all that stuff there. Okay, they've got all that stuff. So part A says, interpret the standard deviation and the standard error. Okay, so standard deviation, that's your average distance from the mean. So we would say the widths of the ice cubes, vary from the mean by the mean of 29.4874. Okay? What did I say? The width of the ice cubes varies from the mean of 29.4874 by 0.093 millimeters, okay, on average. So that is how you interpret your standard deviation. The widths are away from the mean, okay? Now we want to talk about the standard error, okay? The standard error. So, in random samples of size 50, okay, in random samples. So the standard error, okay, remember, your standard error, really, if you're looking at this problem, like this is your standard error. It's the standard deviation part. If you're thinking of a confidence interval, and we have plus or minus a critical z or a critical t, this part after that, that is your standard error. So when we interpret that, what we want to say is, in repeated samples of size 50, okay, in repeated samples of size 50, the sample mean, okay, the sample mean will be about 0.013 millimeters from the true mean on average. So when you're talking about that standard error, you have to bring in the fact of your sample size. Because if you look, here is your sample. This is what the standard error is. The standard error is the standard deviation divided by the square root of your sample size. So when you're interpreting that, what's different between interpreting that and interpreting standard deviation? You have to talk about the size 50. Okay, samples in repeated samples of size whatever. In this case, it's 50. All right? So let's look at the next part. Let's slide this up. It says, do these data give convincing evidence that the mean width of cubes produced this hour is not 29.5? So, What does it mean when they say is not 29.5? Anybody? Nobody knows? All right. I didn't hear anybody. I didn't hear you, Ben. I didn't hear you, Andrew. Didn't hear you guys. So let's do these data. So we can just do that first data. Restate. Do these data. Give convincing evidence. Give convincing evidence. Make sure you're listening because you're not going to be able to read it. That the mean width of cubes is not 29.5. Okay? That's our state. Let's go on to our hypothesis. Well, we know what this is. 29.5. And I think it's what, millimeters? Millimeters. U equals the mean width of ice cubes. So here it is. Here it is. This is what we're going to think about. This is what makes this problem different. Okay, so what makes this problem different? Does it give convincing evidence that the mean width is not 29.5? So that would say the mean is not 29.5 millimeters. Okay? So we got to think about what that means. Okay, we got to think about what that means as we go. We're not going to give it away. So let's do our plan. Okay, so this is still a 1 sample T test for means random, normal, independent, random. It states it was a random sample. The most important of your conditions, right? Random, okay? Because otherwise, everything else doesn't matter. Okay, the most important of your conditions has to do with your center, making sure that this mean means something that's an unbiased estimate. Normal. Oh, it's a beautiful thing. 50 is greater than 30. So we can use the normal approximation. Okay, we like that. And 50 is less than or equal to 10% of the ice cubes, created. All right, really good job there. That's a really, really good job on your state and your plan. A lot of work there, okay, but kind of easy. It's kind of straightforward. So let's go to the do. Do. Ready? Do, the do step. What do we got to do? We got to get a t-score, right? We've got to get a t-score. So the sample we have there is 29.4874. 29.4874 minus 29.5. Well, come on, really? Look how close that is. We're probably gonna be fine, right? Standard deviation. Standard deviation. I guess we could probably just put the standard error there. Let me just see what they did. Because the standard error is the standard deviation divided by the, well, they put it in. Let's test it. Let's test it. Ready? 0.0934. 7, I'll say. Divided by the square root of 50. Now that should be this. That should be my standard error. Okay? That should be my standard error. All right? Try to figure that out. So, what do we have? 29.4874 minus 29.5. Okay? So let's go to the calculator. $29.4874 minus 29.5.